Alright, let's look at part 2 of 3 of finding the probability of events using distributions. So assume that a procedure yields a binomial distribution with a trial repeated n times. Use the binomial probability of x successes given the probability of p of successes on a single trial. So in other words, n is the number of trials, x is the number of successes, so we get 6 out of 9, and the probability of a success is 0.65. We want to find the probability of getting 6 successes. This is the probability of just one success. Well, for a binomial, the easiest way in your calculator is if you hit second bars, scroll down and you'll find the binomial probability distribution function. The order that you have to put it in is n, so the total number of trials, p, the probability of success, and then x. And then don't forget to close the parentheses, you hit enter, and you get your answer. It's not about how to do this by hand, but you don't want to do it by hand, trust me. So this is the actual formula, whereas you can see, you've seen this before with combinations. So this is your n factorial divided by n minus, in this case not r, but x, just using x factorial times x factorial times the probability of success raised to the number of successes times the probability of a failure raised to the number of failures. So this is the piece that's kind of, so if I go through, I know 9 factorial means 9 times 8 times 7 times 6 all the way down to 1. 9 minus 6 is 3. 3 factorial times 6 factorial. So 3 factorial is 3 times 2 times 1, 6 factorial. There's just a bunch of canceling. So I'm going to cancel this 654321 with this 654321. So that just leaves me this piece right here. And then finally I'm going to cancel the 3 at the bottom with the 9. So 3 goes into 9 3 times. 2 will go into 8 4 times. And then that gives me something easier that I can just put this straight in my calculator and get that answer. Phew, right? No way I would go through doing this technique. I'd at least go through this example once so you understand how this formula works, but then I would learn the shortcut. So alright, a brand name has a 70% recognition rate. If the owner of the brand wants to verify that the rate by beginning with a small sample of 10 randomly selected consumers, find the probability that exactly 7, because that'd be 70%, right, of the consumers recognize the brand name. Also find the probability that the number who recognize the brand name is not 7. So what do we know? We know that there's 10, the number in the sample. We want to find the probability of 7 successes. The probability of a success that they recognize the brand was given as 70%, or in decimal 0.7. Once you know this, you can just plug all this in your calculator. We want to find the probability of exact. So I go on my calculator, I put the number of trials in, which is 10, the probability of a success, which is 0.7, the number of successes, which is 7, and I get my answer. So that gives me the probability of exactly 7. Part said would not recognize the brand. Well, not would be the complement, so just simply take 1 minus the probability that 7 would recognize it, and you get 0.733.